Okay, welcome back, guys. So this is going to be kind of weird. If the audio is awful, I'm sorry. I've got to use the mics from my little Elmo thing here, and I also noticed that on top of that, uh, I've got it all the way extended up, and it's still zoomed in pretty good. So we're going to try this out. We're going to see how this works. Okay, so let's kind of pick up where we left off. So we left off with the notes. And in the notes, remember, we uh, talked about how to make a graph, how to make data tables. And now we're going to make our data, or sorry, our graph here. And we're going to use the information from the data table that was an example in our notes. Oh my goodness, I think that sounded weird. We're going to use the data table in the notes as an example to make a graph. And in this case, just because, I think I already mentioned it at the end of the video, this is going to be a bar graph. Okay. Okay. Here I'm pulling all that data up. Okay. So remember, and we're going to go through all the different steps of making a data table, or sorry, my goodness, I'm sorry, I've got data table on the brain. We're going to go through all the steps of making a graph, and hopefully we'll have a good idea of how to make this graph here. So let's see, let me pull up my steps. Okay, got them. Good. Okay, so we first need to find the lowest number on our data table. So our lowest number looking at this, so looking at the average annual precipitation for selected US cities, our lowest annual precipitation is going to be 30.5. So I'm going to write it like somewhere down here just so it's out of the way, because I know I'm going to put my graph up here because this is going to be the best spot up here, specifically because of the names of the cities and the states. So I'm going to write it down here. So my lowest value is 30.5 centimeters, while my highest is going to be, looking at my data table, it looks like my highest is going to be 166.9 centimeters. Okay. So this is going to give me a good indication of how I should space out my graph. It'll give me a good idea of how I should represent the data properly for my graph here, because I don't want to put my maximum. I don't want to put my max range like at 150. I don't want to put my lowest range at 40. I want something that will include this and will also include this, but also at the same time, look presentable on my graph. Okay, so let's start kind of looking at this. Okay, so we've got our lowest and our highest again. Next thing we need to do is that now we need to start organizing our data. We need to, as we have in the notes here, we need to mark our graph appropriately on the x-axis and the y-axis, leaving an equal amount of space for our ranges. And now, again, this is one of those things where it's graph dependent. It depends upon how you want this to look. And there are right ways to make graphs, but it's more about making it look as neat, presentable, and appealing as possible. So what we mean by mark your graph appropriately is realistically speaking making sure everything looks nice and neat, everything looks consistent. So what I'm going to do is that, because I know my highest value is 166.9, my lowest value is 30.5, and on top of that, I know that this is supposed to be a bar graph. We're just going to keep the lowest value. We're going to keep that at 0. And here, we're going to have the highest, we'll have at 200, just because that makes it as easy as possible for us. Now, what do I mean by 0 and 200? Well, let's take a look. So because this is grid graphing paper, the grids actually mean something. These squares mean something. We can use these as tick marks on our graph. So I'm going to set my lowest at 0, and I'm going to set my highest at 200. So that means then I need to have an equal distribution of my values in this range on my, in this case, y-axis. So this is what I mean. I'm going to start all the way here at the tippy top. That's going to be 200, okay? And I need to count down equally till I reach 20, or sorry, till I reach 0. And to do that, I'm going to do this. I'm going to count each line here on the side. Each line here is going to represent a tens place. So how can I make this quicker other than just, counting down? How can I set where my 0 is going to be? I could just count the squares, and I can count 20 squares down, and that's where I'm going to start my 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's my 0, okay? And now I just fill in the rest. So here's going to be 10, 20, 30, 40, 50, 60, 70. You get the idea. I don't have to count with you, or you don't have to listen to me count, but you understand what I'm doing here, okay? I'm organizing my data. I'm organizing my range in a way that's even, that it's consistent, it's neat, and it makes sense to the reader, right? And for the most part, it's easy to graph our material. Okay, so we've got that. So there's my y-axis, or at least the range of my values for the y-axis. Okay, now let's do that for the x-axis. Now, the x-axis is going to be a little different in here. While I'm talking about that, I'm going to do this. The x-axis is going to be a little different just because we're not working with numbers. We are instead working with names, specifically names of cities. So to maybe dress this up, this is what I'm going to do, and I need you to follow along with this. Because they're names, I'm going to write them in this direction. I'm going to write them vertically here on my graph. But first, I'm going to space out. I'm going to space out where I'm going to have my bars and how I'm going to represent this. So I'm going to leave this guy right here, this first column, I'm going to leave blank. So I'm just going to write a tick mark there, and I'm going to take up 2 grid spaces. So 2 squares. So leaving this guy blank, and then I'm going to go 1, 2. And then in here is where I'm going to write the name of our first city, which in this case is Buffalo. Specifically Buffalo, New York. Okay. And then I'm going to repeat that all the way down. So I'm going to leave this one open. I'm going to put a hash there, 1, 2, hash there. My next city, Chicago, Illinois. Okay, rinse and repeat. Next one is Colorado Springs. Okay, leave another space, then 1, 2. Next one is Houston, Texas. Okay, leave a space, 1, 2. Next one is San Diego. And here, I'm just going to keep the paper like this now. California. And after San Diego, we've got Tallahassee, Florida. And then lastly, we have Tucson, Arizona. Okay. All right, and then I'm going to do what I did over here. I'm going to bold in my line here. I want to start at the origin, at my lowest, and then just all the way out to the last variable there, which is Tucson, our last value. Okay, so we've got some that is looking like this so far. Okay, all right, so we've got our spaces. We've got these organized correctly because think about it. If we were to write these horizontally, we'd be writing like Buffalo, Chicago, Colorado. They'd be staggered and it'd just look bad. So writing them, vertically, writing them in this direction will make it more appealing, and it'll save us some space on our graph, obviously. Okay, so we've got our variables, all of our listed variables for the x-axis, all the whole range for our numerical range here for the y-axis. Okay, so now what do we do? Okay, well now we need to label our axes. So our x-axis, these are just cities. So we could do city, and then you could keep it the same thing as your data table. So we could do city, state. Okay, you could do that. You could just have cities. It doesn't matter in this case as long as you've got cities somehow, somewhere. Okay, but it's at the bottom. It's nice and neat. In this case, it's at the same direction as our x-axis. We wouldn't want to put this guy vertically. That would just look weird. What we do want to put vertically is this label here. So this label is going to be our average. I'm just going to write out average. Our average annual precipitation. Oh, I think I spelled annual wrong. Oh my goodness. Annual. Yeah, I spelled it wrong. ANNUAL, sorry. Precipitation. And we specifically are measuring that in centimeters. Okay. This looks all good. Then, so now we've got x-axis, y-axis labeled. Now we need to write the title at the top. So again, we can use the same title as our data table. The data table's title is pretty much just a combination of these two. Remember, it's the average annual precipitation for selected U.S. cities. Now, typically, you want to make sure your title it fits within your graph. I went over a little bit, it's fine, but obviously you don't want a title that just continually, just completely goes past your entire graph. If it does, like, probably I should have put this under here, but it's not that big of a deal because it is so close. I mean, it's pretty close. Okay, it's fine. Okay, so we've got our title, we've got our axis labels, we've got a nice range here. It's evenly distributed. We're counting by tens. Each little square here is increases by 10. We've blocked out our cities here. Okay, so now this would be the point in which and it's weird that it's all the way at the bottom. Where I've got number 6. Determine the type of graph you're going to make. But it should be pretty obvious. At this point, it should be obvious. Here, we could be doing a line graph. It's very unlikely. It is possible. But in this case, we already know we're doing a bar graph. Because our graph is pretty much, it's almost been made for us, right? All we have to do now is just more or less just fill in the empty blocks here. That's all we have to do. Okay, so we've got to determine, but more importantly, how do we determine? Well, if we go back to our notes, we look at the definition of bar graph, of circle graph, of line graph. We know that line graphs are defined as a graph that compares, follows a trend that compares two variables over a period of time. We don't have really a period of time here. All we have we're following cities. We are checking out the cities, and we're seeing how much rainfall they have at that time. Okay, or at how much rainfall they have on average over a span of a year. So we're not really interested on the precipitation of one particular place over the span of a year. We're looking at different places and wanting to compare visually the differences in rainfall between each of these cities. So a line graph won't do that, because then all a line graph will show is it'll just show it'll just show this weird line going across all of this, and more or less implying that all of these are connected, but they're not. They all have different precipitations due to the fact that they're all at different kinds of climates, all different regions, more or less. Okay. Buffalo, New York is very, very different than Tucson, Arizona. I can guarantee you that. And same thing with San Diego. Okay. These two are practically deserts. This one is a desert for the most part. Okay. Okay. So we've determined the type of graph we're going to do here, and it's going to be a bar graph. Okay, so we should have a visualization of what this will look like in our heads already. Okay, now plot our data. So again, this is graph specific. So because this is a bar graph, what we want to do is we want to properly uh, uh, and accurately and neatly show these graphs to be as close to the real thing as possible. So this is what I'm going to do. I'm going to make the bars and then I'm going to fill them in with a color. But how I'm going to fill or how I'm going to draw these bars is going to be very specific, okay? Okay, so what I'm going to do is I'm going to close up. I'm going to like zoom in here and I'll show you. Okay, so let's start with Buffalo, New York. Okay, so we're going to start with Buffalo, New York here. So Buffalo, looking at our data table, Buffalo, New York had an annual precipitation of 98.0 centimeters. So what I'm going to do is that I'm going to come up here to 90, and I'm also going to make sure that I'm in line with my Buffalo, because remember, we're going to use both of these squares here for Buffalo, and everyone else will get 2 squares as well. But I'm going to start here. I'm going to run my finger up to 90 here. Because I know it's 98, I'm going to more or less eyeball where 95 is at. So 95 is going to break even, like say like right there. Well, I can just kind of figure out where that space is. Maybe that's 96, 97, 98. I'm going to put a marker there. And then I'm going to take my ruler. And I'm going to try to keep this as straight as possible. Draw my line. And then just finish my box. Okay. Hold this. Do that. And then I've got my bar for Buffalo, New York. Let's now try Chicago. So Chicago had an average rainfall of 91.0. So same thing, only in this case, because it's not above 95, it's going to be just one little tick mark above 90, but make sure that you're in Chicago. So go down to here, make sure you're in the right box. I am going to mark it right there. Take my ruler, make that nice and straight up top, and then I'm going to hold my sides of the bars here. Boom. Okay, so let's do it for the rest of these guys. Okay, we're going to take a look at all the different places and then plot all of this correctly. And I'm going to just do that real quick. Okay, and then here is everything all drawn in. Okay, so and then we can just look at it before we color it in. Let's talk about, what we're seeing here. So we can definitely see, clearly Buffalo, Chicago, roughly about the same. Tallahassee just taking off, man. I mean, Tallahassee just crazy how much water it gets. Same thing with Houston. But then we've got our 3 here: Colorado Springs, San Diego, and then also Tucson, just really, really struggling to get some water. Okay. And this is the point of making a bar graph. We're able to visually see the differences between all these guys. Okay. Now, you must be asking, well, Mr. Sheeline, isn't there a better way to show this? Like, couldn't we have shown like an increase, like maybe start with Tallahassee over here, or sorry, San Diego over here, and then work our way up to Tallahassee over here? Yes, you could have, definitely. Could you have started Tallahassee over here and then show the decline as you get over to San Diego? Yes, you could have. I just represented it this way because this is how we wrote it in our data table, right? This is following the order. The order of the cities is following the order in which we placed it in our data table. Had we had, or if we wanted to show, greatest to least or least to greatest, our data table should have reflected that. Okay. And it probably should have, but this is fine too, because we can still compare all the different, what's it called? Just because we have a low number of cities, we can still compare the differences between all of these. Okay. Okay, so let's now, we've connected the dots. Let's color in the bars. Okay, I'm just going to color these in real quick. Or actually, I'm not even going to do that. I've got a separate one that's all ready to go, just so I don't have to color it again. And here's what it looks like colored in. Okay. So you can see that difference. Just look at that difference of the color. See, here's without color, and then here it is with color. Look how nice and neat this looks. Look how clear it is. Again, realistically speaking, probably should have had this from greatest to least or least to greatest, whatever, whichever we would have done. But again, we're following the order in which things were put in our data table. Okay, one last thing. This is a complete option here. Something that a lot of graphs and a lot of people do with their graphs, and sometimes with bar graphs, depends how busy they want to make it. Some people will actually write the values that this represents at the very top. So, for instance, Tallahassee, I'm going to pick on them. It had 166.9 centimeters of annual rainfall on average. So what they'll do is they'll put like a little dot up here at the center, and they'll write like 166.9. Okay. Now sometimes they will add the units in next to it. Sometimes they don't. Most of the time they don't because it's already mentioned over here. But they'll put the values up top. So not only do you get to see the visual differences between them, you can also know what the values are without having to reference the data table again. So then like Tucson would be 30.5. San Diego would be what, 25.1. Houston would be 117.0. Colorado Springs would be, let's see, 41.2. Chicago would be 91.0, and then Buffalo would be 98.0. Okay. Because it just makes it that much easier to see things. So hopefully you've seen this before, but in case you haven't, I mean, that's it. And that's all it's there for, is just to reinforce the values seen on here so you can get a better understanding of the differences between the values. In this case, the differences in annual rainfall. Okay, so super simple. This is our first example with a bar graph. We're going to continue working on, all the other different bar graphs, all the different types of graphs, line graphs and circle graphs. They're all going to be single variables, double variables. So in this case, and I even said that wrong, it is single. So we're just going to be focusing on like a single variable on the x-axis, a single variable on the y-axis. We're not going to overly complicate things. We're going to keep it simple like this. So don't worry, because again, we're also making this by hand. Actually, and before I let you guys go, just some other ideas. We could have capped this if we wanted to. We could have capped this at 180. We didn't have to go to 200. That's one idea. We could have stopped it there. We could have stopped it at 170. Doesn't really matter. Something else, we could have, instead of going by 10s, we could have gone by 20s, which would have shortened our graph. We could have gone by, each square could have been 15, could have been 5. What matters is that you have a nice looking graph, and it's big enough, it's proportional, it distributes the data in a way that it's easy to read, and it doesn't skew the interpretation of the reader or the reader's interpretation of the data. So for instance, you probably wouldn't want to go by like, as like an example, and to sketch it like over here, you wouldn't want to have your y-axis. You wouldn't want to count by like 50, because then if like each box was 50, you go like, so here's, and if you still went to 200, here's 150, here's 100, here's 50, and then here's 0. If you would do that, you're just not really representing the differences between these all that much. So if we still did this, but I'm going to, since it's all scaled down, I'll just use one box. So like Buffalo would be like, Buffalo would be like up here. Chicago would be like right somewhere about like right here. And then there's Chicago. And then Colorado Springs would be like right here, right? Like it just, you wouldn't get the full effect of how this information is different. Does it still show differences? Yes, it does still show differences. But is it as impactful? Does it really show like the tremendous differences between all of these guys? I would argue no. It just looks, it doesn't look as good. It doesn't really show, and it's cramped, it's small, and you just don't want it, because especially right here. So if this is 25, so if that's 25.1 and this is supposed to be 30.5, they're so close together, it's hard to see that they're like, you could mistake those as being the two of the same value. But because our range is so big, or sorry, our range is so small, our each block is equivalent to 50, 50 units, whatever those units are, in this case centimeters. We didn't have to increase the height of our box here all that much, of our bar here all that much, and they almost look at the identical height, and you just don't get a good idea. So again, you want to make sure that your y-axis represents your data accurately, so that it looks like it looks like this, where you can clearly see the differences, especially in values that are closer, a little bit closer, and not this, where it's hard to see those differences in values that are similar, that are close together. Okay, so if you still have any questions, make sure you let me know. Talk to me, send me a text on Remind, email me, whatever it has to be. Subscribe to this channel if you guys want to know when I'm posting videos. They're just obviously school-related videos. So if you still want to know when something's going up, subscribe. If you still have questions, get a hold of me. If not, then I will see you in the next one, guys. Take it easy.